FAR 91.129 Operations in Class D airspace. If you've read the airspace section, you know that Class D airspace generally extends upward from the surface to 2,500 feet above the airport elevation. Its radius around the primary airport varies depending on the specific needs of that airport. I've seen the radius vary from as little as 3 nautical miles to 7 nautical miles, with a typical radius being a little less than 5 nautical miles. You'll be able to determine the specific size of an airport's Class D airspace by looking at the aeronautical sectional chart. The Class D airspace looks somewhat like a can of tuna, since it has a short, cylindrical shape. Airports in Class D airspace have an operating control tower. The purpose of a control tower is to provide information and instructions to airplanes taking off and landing at the primary airport within that airspace. The primary airport, the one that's usually in the center of the tuna can, is the airport for which that airspace, Class D airspace that is designated. In other words, it's possible to have one or more additional airports lying within Class D airspace. These airports are often called satellite airports, signifying that they orbit or lie close enough to the primary airport to be within its Class D airspace. Equipment required. The minimum equipment required to operate within Class D airspace is a two-way radio. You can, however, request permission from ATC to fly into or out of this airspace without a radio. You might, for example, need to take your airplane to another airport to have the radio repaired. By calling ATC, in other words the tower controllers, on the phone, they'll provide you with instructions for departing and or arriving at the airport without two-way radio communication. Arrivals and fly-throughs. If you want to fly through this airspace or land at the primary airport, you must establish two-way radio communication with the ATC facility that is responsible for that Class D airspace. Normally, this ATC facility is the control tower located at the primary airport. Once established, you must maintain communication with the air traffic control tower while in this airspace. In other words, you must give the tower controller a call before entering the tuna can boundaries, have them acknowledge you, and once inside the can, you must maintain communication at all times. Pilots sometimes become confused about the precise definition of established communication. Technically, you've established communications anytime ATC acknowledges your aircraft call sign, the airplane's number, such as November 2132 Bravo. For instance, on your initial call, while outside or above the physical dimensions of the tuna can, you give the tower your position, altitude, destination, and any requests you have. They'll normally call you back using your aircraft call sign and give you directions for entering the traffic flow around the airport. If the controller says, November 2132 Bravo, stand by, you've technically established communications and may continue into the tuna can toward the airport. If the controller says, aircraft calling on fire tower, stand by. That is, if you aren't called by your N-number name, then you have not established communications and should remain outside or above the tuna can. Of course, if the controller says, November 2132 Bravo, remain clear of Class D airspace. They don't say tuna can, by the way. Then you must follow their instructions even though two-way communication has been established. These communication requirements are in force even if you are landing at one of the satellite airports within the Class D airspace. In other words, if another airport lies within the boundaries of the tuna can, typically an airport without an operating control tower, and you're interested in landing there, you must establish two-way radio communication with the air traffic control tower at the primary airport before entering this airspace. You must maintain these communications during your flight to this airport. Departures. If you're departing from the primary airport, you must establish and maintain two-way radio communication with ATC within Class D airspace. In other words, don't take off without calling the tower and listening to them while in the tuna can. Suppose you're taking off from a non-tower satellite airport within Class D airspace. Do you still need to call the ATC facility for the primary airport? Yes. You must establish and maintain two-way radio communication as soon as practical after departing. In other words, take off and give the tower at the primary airport a call as soon as it's reasonable for you to do so. Let them know what you're doing. Follow the directions and keep listening to them while you're anywhere within the tuna can. Communications failure. Your radios could give up the ghost en route. Does this mean you can't fly back into the Class D airspace you departed from? Not necessarily. A provision in this regulation allows you to enter Class D airspace under VFR conditions. We'll explain VFR in more detail in Chapter 9. In other words, you can get back into the tuna can as long as you have weather conditions at or above basic VFR minimums. How do you do it? Simply fly to the airport, enter the traffic pattern, watch the tower for light signals, and land when you receive a steady green light from the tower. Minimum altitudes. The important section here is the part saying that you must stay at or above the glide slope until a lower altitude is necessary, when approaching to land on a runway served by a visual approach slope indicator, VASI, pronounced VASI. We'll discuss VASIs in Chapter 7. For now, accept the fact that a VASI consists of light bars that tell you if you're on the proper glide slope for the runway you're approaching. Takeoff, landing, taxi clearance. No person may, at an airport with an operating control tower, operate an aircraft on a runway or taxiway, or take off or land an aircraft, unless an appropriate clearance is received from ATC. A clearance to taxi to the takeoff runway assigned to an aircraft is not a clearance to cross that assigned runway or to taxi onto that runway at any point. It is, however, a clearance to cross other runways that intersect the taxi en route to that assigned takeoff runway. Likewise, a clearance to taxi to any point other than an assigned takeoff runway is a clearance to cross all runways that intersect the taxi route unless specific hold short instructions have been given. FAR 91.130 Operations in Class C airspace. Class C airspace is larger than Class D airspace in that it has two cylindrical components instead of the single tuna-shaped can Class D airspace. Class C is a double-decker tuna can. The physical dimensions of Class C airspace consist of a lower tuna can having a radius of 5 nautical miles and extending vertically from the ground to 4,000 feet above the airport elevation. The upper and larger tuna can has a radius of 10 nautical miles. It starts at 1,200 feet and extends vertically to 4,000 feet above the airport elevation. For the sake of continuity, we'll refer to Class C airspace as the double tuna can. I do feel it's necessary to mention that no dolphin have been hurt, injured, or eaten in the writing of this material. Simply stated, Class C airspace goes with airports that handle larger, faster airplanes. Generally, this means significant quantities of commercial traffic. It's established to keep the small airplanes and bigger airplanes from bumping into one another. Since there are faster airplanes involved, it makes sense that the airspace must cover more area. Refer to Chapter 9 for more information on Class C airspace. As with Class D airspace, there is a primary airport in the center of the double tuna can. This is the airport for which Class C airspace was established. The double tuna can usually sits directly over this airport. As with Class D airspace, there may be satellite airports within the boundaries of Class C airspace. In other words, there may be other airports with and without control towers within the surface area covered by the double tuna can. You're going to find there is very little difference between the requirements for flight in Class C airspace compared to Class D airspace. Whether you're in the single or double tuna can airspace, the requirements are essentially the same. Let's examine the Class C requirements. General requirements. All operations in Class C airspace must comply with the previous regulation FAR 91.129. In other words, the operating rules are essentially the same as in Class D airspace. This makes sense since both Class D and Class C airspace have primary airports with operating control towers. Therefore, they should have similar requirements for aircraft operations. Traffic patterns. If you're taking off or landing at a satellite airport within Class C airspace, you must comply with the FAA arrival and departure traffic pattern established for that airport. There's nothing new here. Just because the primary airport is a little bit busier, there's no reason why you should do anything different at one of the satellite airports than you would do for Class D airspace. Communications, arrival and through flight. If you want to land at the primary airport in Class C airspace, or if you just want to fly through that airspace, you must establish and maintain two-way radio communication with the facility providing air traffic services prior to entering that airspace. In other words, the double tuna can of airspace may be controlled by either a tower, an approach control facility, or a combination of both. Your aeronautical sectional chart, charts used for aerial navigation, will generally instruct you to contact approach control on a specific frequency within 20 nautical miles from the primary airport, having Class C airspace. Of course, you're required to establish and maintain two-way radio communication prior to entering Class C airspace. Communications. Departing flight. If you're departing the primary airport within Class C airspace, you must establish and maintain two-way radio communications with the tower prior to departure. If the controller hands you off to departure control, talk and listen to the departure controller until you're out of the double tuna can, in other words, the Class C airspace. If you're departing a non-tower satellite airport lying within the surface boundaries of Class C airspace, you must establish and maintain two-way radio communications with the approach or departure control facility having jurisdiction over that airspace. Do this as soon as practicable after departure. An approach or departure control facility is usually the ATC facility having jurisdiction over Class C airspace. In the rare event the satellite airport has an operating control tower, do exactly as you would do if you were departing the primary airport having an operating control tower. In other words, establish communications with the tower at the satellite airport and follow their instructions. Equipment requirements. The minimum equipment required to operate within Class C airspace is a two-way radio and a transponder with altitude reporting capability, as per FAR 91.215. You'll learn more about transponders shortly. These are electronic devices that allow your airplane to be identified on the approach or departure controller's radar scope. The altitude reporting capability allows the controller to see your altitude on his or her radar screen. FAR 91.131 Operations in Class B airspace. Class D airspace was small, a single tuna can. Class C airspace was slightly larger because there were bigger and faster aeroplanes there, a double tuna can. Class B airspace is the biggest of these tuna can stacks of airspace. It usually extends up to 10,000 feet MSL and often has horizontal dimensions of many miles. The airspace is larger than Class C or D airspace because its primary airport has many very large and fast airplanes like Boeing 747s and DC-10s and much IFR activity. In some cases, Class B airspace looks like several stacked cans of tuna. Actually, it looks more like an inverted wedding cake with individual tiers or floors contributing to its structure. Extra tiers allow faster jet airplanes to make long arrivals and departures into and out of the primary airport, while remaining within the protected airspace. The following are the requirements to take off or land at the primary airport, or operate within the wedding cake airspace. Operating rules. First, you must follow all the rules of FAR 91.129, those referring to Class D airspace, while in Class B airspace. In addition, before you can enter Class B airspace, you'll need a clearance from the ATC facility having jurisdiction over that airspace. A clearance is essentially verbal permission for entry into this airspace. This is different from the entry requirements for Class C or D airspace, which only required that you establish and maintain two-way radio communication before entry. Pilot requirements. You need to be at least a private pilot to take off or land at the primary airport in Class B airspace. If, however, you are a student pilot or recreational pilot seeking private pilot certification and have met the requirements of FAR 61.95, then you may take off or land as well as fly in Class B airspace. By the way, FAR 61.95 is not included in this book. It identifies the requirements for student pilots to enter Class B airspace. Your instructor will give you the details if he or she intends to have you tooling around with 747s. No matter how confident you may be as a student pilot, there are some primary airports within Class B airspace that are just too darn busy for you to take off or land at unless you have a private pilot certificate or better. See Appendix D of FAR 91, Section 4, for a list of these airports not included in this book. Equipment required. The minimum equipment required to operate within Class B airspace is a two-way radio with all the frequencies needed for communication with ATC, a transponder with altitude encoding capability, and, for IFR operations, a functioning VOR receiver. FAR 91.133 Restricted and Prohibited Areas. Across the United States, you will find areas known as Special Use Airspace. Restricted and prohibited areas are part of this Special Use Airspace group. Restricted areas, while not wholly prohibited, subject flights to certain restrictions. These restrictions may be based on time, altitude, or other requirements. Restricted areas. Operations within a restricted area assume that pilots have the permission of the controlling agency responsible for that area. It also requires that pilots follow whatever restrictions are imposed by the agency. A restricted area is often used for military activities. Fighter pilots might be performing their tactical maneuvers and wild aerial dances designed to frighten off an arch-enemy. These dances often frighten off little general aviation pilots too. You should avoid these areas unless you have permission to enter. What can you do in a prohibited area? it's reasonable to say you can do a lot less than in a restricted area. There are certain areas of the country where flight is prohibited. For instance, the capital of the United States in Washington, D.C. is surrounded by a prohibited area. I doubt that you'll get permission from the U.S. government to fly into this prohibited area. This is usually the case with most prohibited areas. They're prohibited for a good reason.
A friend living on the East Coast played a nice little practical joke on one of his first flight instructors. He obtained a few large color aerial photographs of the Capitol building and had them converted into smaller 3-inch by 5-inch photographs. He flew a solo cross-country near the Washington, D.C. area and took a few actual photographs of the trip. When he met his instructor the following week, he interspersed his Capitol Dome shots in with the scenic shots. Giving them to his instructor, he said, "Here are a few aerial photographs I took from the plane." When his instructor saw the Capitol shot, his eyes bugged out and said, "Oh man, you're going to owe me a few bucks for this one." What is aviation if you can't have a little fun with your instructor?
FAR 91.135 Operations in Class A airspace. Class A airspace is airspace starting at or above 18,000 feet MSL. You can't even be in Class A airspace without an instrument rating, so I won't even discuss it here. I will, however, discuss it in Chapter 9, Airspace. FAR 91.151 Fuel Requirements for Flight in VFR Conditions. This regulation states that no person may begin a flight in an aeroplane under VFR conditions unless, considering wind and forecast weather conditions, there is enough fuel to fly to the first point of intended landing and, assuming normal cruising speed during the day, to fly for at least an additional 30 minutes. During night flight, the required fuel reserve is increased to 45 minutes. Obviously, the risks in running out of fuel at night are greater than during the day, so a larger cushion is desirable. FAR 91.155 Basic VFR Weather Minimums. As you'll discover in Chapter 9, a VFR pilot must always maintain a minimum visibility and clearance from any clouds while flying. Known as basic VFR weather minimums, these visibilities and cloud clearance requirements vary depending on the particular class of airspace in which you are flying. FAR 91.157 Special VFR Weather Minimums. We'll leave the discussion of Special VFR for Chapter 9. FAR 91.159 VFR Cruising Altitude or Flight Level. Collision avoidance in automobiles is greatly enhanced when drivers stay on their side of the road. To assist in this process, road dividers prevent stray drivers from venturing across the forbidden yellow lines. Like car drivers, pilots also have roads in the sky. These roads are known as federal airways. Since many pilots use these federal airways, as well as non-airway routes, it makes sense to separate airplanes vertically by having pilots fly at different altitudes for different directions of flight. In this way, altimeters become vertical traffic separators that keep pilots from bumping into one another. This regulation states that during VFR flight, when operating more than 3,000 feet above the surface, you are to fly at an altitude appropriate for your direction of flight. If you are on a magnetic course of 0 degrees through 179 degrees, you should fly any odd 1,000-foot MSL altitude plus 500 feet. Altitudes such as 3,500 feet, 5,500 feet, 7,500 feet, etc. are appropriate for that direction. While on a magnetic course of 180 degrees through 359 degrees, you should fly at an even MSL altitude plus 500 feet. Altitudes such as 4,500 feet, 6,500 feet, 8,500 feet, etc. are appropriate for this direction. This provides you with a minimum 1,000-foot clearance from other VFR airplanes heading in opposing directions. Are you wondering who uses the even or odd 1,000-foot altitudes? IFR pilots do. If you're flying on an airway, you can probably expect some IFR traffic 500 feet above or below your aeroplane. Since you'll be in VFR conditions, you should be able to see and avoid these airplanes. And in VFR conditions, they have the same obligation toward you. Comforting, isn't it, to know that everyone is looking out for everyone else? Remember, these cruising altitudes apply only if you're operating at more than 3,000 feet AGL, in other words, 3,000 feet above ground level. Operations at and below 3,000 feet AGL can be flown at whatever altitude you choose. These rules don't apply if the aeroplane is turning. If you're maneuvering while practicing your stalls, steep turns, and other activities, you're not required to maintain a specific altitude. FAR 91.203 Civil Aircraft Certifications Required. Several years ago, I wanted to discover if a student of mine knew what documents were required to be carried on board the aircraft. I said to him, "Hey Bob, what things are required to be in the airplane for it to be legal for flight?" He looked at me, scratched his head, and said, "The pilot?" I gave him the same look that I gave the seafood waiter who was supposed to bring me a twin lobster dinner. Instead, he brought me a lobster and a crab. I said, "Hey, what gives? I ordered twin lobsters." He said, "Well, they're fraternal twins." In both cases, I lifted a single eyebrow and radiated one of those "you're going to owe me $5" looks. There are 4 items that must be on board the aircraft at all times when it's being operated. 2 of these are certification documents: the airworthiness certificate and the registration certificate. The other 2 items are the airplane's operating limitations and its weight and balance information. These last 2 items may be found in the Approved Airplane Flight Manual or in approved manual materials, markings, and placards, or any combination thereof in the airplane. The first certification document is the Airworthiness Certificate. This is issued for a specific aircraft at the time of manufacture, and it remains valid as long as the aircraft receives the required annual inspection by a licensed mechanic and meets other legal requirements. The Airworthiness Certificate must be displayed where it's visible to passengers. Take a look the next time you get on board a commercial airliner. There, between the smiling cabin attendant and the lavatory door, will be a plastic pouch bearing the Airworthiness Certificate. It's supposed to make you feel secure. Frankly, I'd feel better if they showed me the pilot's license. I know the airplane can fly. The second certification document that must be on board is the registration certificate issued to the owner of the aircraft. The registration need not be displayed. It just needs to be in the aircraft. FAR 91.207 Emergency Locator Transmitters. All U.S.-registered civil airplanes must be equipped with an automatic-type emergency locator transmitter, otherwise known as ELT. The ELT must be in operable condition. These transmitters are impact-activated devices that send out pulse transmissions on the emergency frequency of 121.5 MHz and 243 MHz. Should you land hard enough, usually a 5G or greater impact, or crash, an internal arm of the transmitter is activated, and the transmission begins. Satellites and search and rescue pilots can easily track ELT signals to find downed pilots.
As a flight instructor, I've heard of students landing hard enough during practice to activate the ELT. Although the airplane wasn't damaged, airplanes can take a licking and keep on ticking, the ELT went off. Like Pinocchio's nose, ELTs don't lie. Imagine a student returning from touch-and-go practice. Tires are smoking, not really, and the instructor is suspicious. He asks, "Did you have a hard landing?" The student straightens and replies, "No way, dude. They were all greasers." The instructor says, "Well, let's see how greasy they were," as he tunes the airplane radio to 121.5, the emergency frequency. Suddenly, the speaker wails with that attention-getting sound. "Dude, it seems like nowadays you can't get away with anything. What a bummer."
The most important thing to remember about your ELT is that the batteries must be replaced or recharged if the device has been in use for more than 1 cumulative hour, or when 50% of their useful life, or life of charge, has expired. If you want to manually test the aeroplane's ELT on the ground, you may do so during the first 5 minutes past the hour. You're limited to 3 audible sweeps during the test. Additionally, each ELT must be inspected within 12 calendar months after the last inspection for proper installation, operation, battery corrosion, and for the presence of a sufficient signal radiated from its antenna. FAR 91.209 Aircraft Lights.
"Bobby, it looks like I'm going to have to lecture you all afternoon. Several years ago, a truck driver was driving beyond official sunset with his headlights off. A highway patrol officer gave chase. Feeling a little ornery, the truck driver didn't stop for several miles. When he did stop, the officer was fuming as he exited his vehicle. The truck driver knew he was in trouble. Approaching the truck, the officer said, "Hey buddy, I've been chasing you for several miles to tell you your lights need to be on past sunset. Why didn't you stop?" The truck driver thought fast and said, "Well, officer, several years ago, my wife ran off with a fellow from the highway patrol, and quite frankly, I just thought you were trying to bring her back." The moral of the story is, Bobby, turn your lights on from sunset to sunrise.
Official nighttime for aeroplanes is from sunset to sunrise. No person may operate an aircraft during this period unless it has lighted position lights. These are the lights that make it easier for pilots to see each other at night. An easy way to remember the color of these lights for aeroplanes is to ask the following questions. What color means it's all right to go? Yes, a green light, and that's the color of the light on the right wing. What do we call the radical left-wingers in our political system? Yes, we used to call them commies or reds. Therefore, left wings have red position lights. The tail carries a white light. These lights are called position lights for a good reason. Since it's difficult for someone outside the airplane to tell which way an airplane is headed at night, specific colors are needed to help get the job done. For instance, suppose you see a white light and a red light. Which direction is the airplane traveling? Of course, it's moving from right to left. A white light and a green light means the airplane is moving from, you guessed it, left to right. A red light on the right and a green light on the left means the airplane is coming towards you. This becomes especially obvious if the distance between these lights is increasing. Airplanes with an anti-collision light system must have these lights on at all times when the airplane is in operation. This typically consists of white strobe lights or a red rotating beacon. Pilots are allowed to turn off the anti-collision lighting system if the pilot in command determines, because of the operating conditions, it is unsafe. In hazy conditions at night, strobe lights can be quite distracting. but don't turn them off unless it presents a real serious problem. On one flight, where we were in the clouds, my right seat, non-pilot passenger, became annoyed by the flashing white light on the right wing. He looked over at me and said, "Hey, turn off your blinker if you're not going to make a turn." If you're piloting a seaplane, you may not anchor an aircraft unless it has lighted anchor lights or is in an area where anchor lights are not required on vessels. A friend had a student who was a crusty old mariner. He spent so much time on boats that he'd show up for the flight lesson with clams, mussels, and lobsters still attached to his jeans. During one pre-flight, he untied the ropes and, out of habit, threw them away from the airplane while yelling, "Cast off! Cast off!" If you're in Alaska, where nighttime and daytime take on different meanings, another method of determination is used. Read the next sentence only if you're an Alaskan. In an igloo wearing seal furs. In Alaska, during the period a prominent unlighted object cannot be seen from a distance of 3 statute miles or the sun is more than 6 degrees below the horizon, the aircraft must have lighted position lights and an anti-collision lighting system in operation. In these northern territories, the sun could shine for 20 hours at a stretch in the summer months. That sure adds to some excitement to those 4th of July fireworks shows, doesn't it? You can hear the explosions, but you don't know where they're coming from. FAR 91.211 Use of supplemental oxygen. It is in your best interest, not to mention your passengers, to have full mental capability while piloting an airplane. Reducing oxygen flow to the brain is one of the quickest ways to get it to act really weird. To keep us from acting any weirder than we are genetically programmed to do, the regulations require the PIC and any required flight crew members to use supplemental oxygen when flying for more than 30 minutes above 12,500 feet, up to and including 14,000 feet. If you go above 14,000 feet, you must use oxygen from the moment you exceed that altitude. Over the years, I've had pilots come to me and say, "Hey, couldn't I be at 13,500 feet for 29 minutes, descend 12,000 feet for a few seconds, then immediately climb back to 13,000 feet, thereby avoiding the use of oxygen?" Legally, the answer is yes. But a question like this makes me think that the pilot's brain has already suffered the debilitating effects of oxygen deprivation. The only people we haven't talked about yet are the passengers. Hopefully they're not in back asleep because you forgot to provide them with oxygen. According to the regulations, you, the pilot in command, are required to provide each occupant of the aircraft with supplemental oxygen when operating at altitudes above 15,000 feet MSL. The rule specifically states provide, not use. Common sense dictates that it should be used, of course, but it's the old "you can lead a horse to water" situation. You will notice that if some of your passengers choose not to use oxygen above 15,000 feet, they will be very, very quiet. That's because they've probably dozed off or are unconscious. All these altitudes are MSL altitudes. Since you might someday fly a pressurized airplane, these rules also apply to cabin pressure altitudes. For instance, if you pressurize the cabin to an altitude simulating 13,000 feet, then you and the flight crew are required to use supplemental oxygen for that portion of the flight exceeding 30 minutes at that cabin altitude.
One last word on the use of supplemental oxygen. Don't get it near fire. That's deadly. The airlines are always telling their passengers to extinguish their cigarettes before putting on the oxygen mask. Yes, they still smoke on international flights. Frankly, I'm amazed that we need to tell anyone this. After all, who would smoke in an oxygen tent? Perhaps an even more appropriate question to ask is, who would do it a second time?
FAR 91.215 ATC transponder and altitude reporting equipment and use. Transponders are electronic devices which allow an aircraft's position to be precisely identified on radar. Transponders absorb radar energy, modify it with a special numerical code, then send that numerical code back to the radar. Controllers, asking pilots to squawk, set in the transponder's window, a 4-digit code, can see those exact numbers on the radar screen. This makes for a positive identification of each aeroplane. These transponders are known as Mode 3/Alpha 4096 code capable transponders. The 4096 represents the number of possible combinations of codes capable of being set in the transponder. For the math maniacs, there are 4 windows, each with 8 possible numbers. 8 to the 4th equals 4096. Some transponders have Mode C capability, otherwise known as altitude reporting capability. This means they can display the aeroplane's altitude on the radar screen. You'll learn more about using transponder in Chapter 8. For now, let's understand when and where we're required to use the transponder. We'll also assume you aren't flying either a balloon or glider, and that your aeroplane was originally certified with an engine-driven electrical system, or hasn't been subsequently certified without such a system. After all, if there's no electrical source on board, a transponder isn't going to work. Transponders with Mode C capability are required if operating in any of the following: 1. In Class A, Class B, and Class C airspace areas. 2. In all airspace within 30 nautical miles of certain airports listed in Appendix D, Section 1 of FAR Part 91, from the surface upward to 10,000 feet MSL. I won't bother to list these airports since they can be identified from your aeronautical sectional charts by thin, magenta, circular rings. 3. In all airspace of the 48 contiguous states and the District of Columbia at and above 10,000 feet MSL, excluding the airspace at and below 2,500 feet above the surface. 4. In the airspace from the surface to 10,000 feet MSL, within a 10 nautical mile radius of any airport listed in Appendix D, Section 2 of FAR Part 91. This also excludes the airspace below 1,200 feet outside the lateral boundaries of the surface area of the airspace designated for that airport. At the time of this writing, there is only one airport listed in the appendix. It's Logan International Airport in Billings, Montana. One last thing about this regulation. It requires you to keep your transponder turned on while in the airspace listed above, or in any controlled airspace. In addition to keeping it turned on, you must also operate it in Mode C, the altitude mode, if you are so equipped. You are probably wondering, what do I do if my transponder or Mode C fails in flight, or fails at some intermediate stop on a cross-country flight? Well, fear not. ATC can waive the transponder requirements, regardless of the airspace in which you're flying. ATC can honor this request at any time. Simply call the center or approach controller with your request. If, however, you don't have a transponder, ATC wants at least a 1-hour notice before they approve a flight in an area requiring a transponder. In other words, if you want to depart the primary airport in Class C airspace, you should call the tower at least 1 hour before departure and request a waiver if your aircraft is not transponder equipped. FAR 91.303 Aerobatic Flight. Aerobatic flight is defined as an intentional maneuver involving an abrupt change in an aircraft's altitude, an abnormal attitude, or abnormal acceleration, not necessary for normal flight. From that description, it sounds like I was doing aerobatic flight on every solo flight as a student pilot. If you intend on doing aerobatic flight as it's defined, then you must comply with the following rules. First, you may not conduct aerobatic flight over a congested area of a city, town, or settlement. Nor can you conduct aerobatic flight over an open-air assembly of persons or when less than 1,500 feet above the surface, or when the flight visibility is less than 3 statute miles. You may not conduct aerobatic flight within the lateral boundaries of the surface areas of Class B, C, D, or E airspace designated for an airport. The surface area for these classes of airspace is identified on your aeronautical sectional chart by dashed or solid lines. You'll learn more about airspace identification in the airspace chapter. If you're thinking about doing aerobatic flight within 4 nautical miles of the center line of a federal airway, think again. This isn't allowed. The last thing the FAA wants is some guy doing loops on a crowded highway in the sky.
Check it out, dude, aerobatics is just plain fun, and you'll be easily hooked. In fact, it's amazing to me that there isn't a special wing at the Betty Ford Center for aerobatic withdrawals. Whoa. Trust me, you'll have tons of fun, even with the restrictions. Whoa, you'll be like, whoa, then whoa, then you'll be like, whoa.
I often tell people that I had an opportunity to go up with the famed Bob Hoover, an extraordinary airshow pilot, at Oshkosh in 1992. As I say this, I watch the other pilots wilt with envy. Then I tell them that we went up in an elevator at the Oshkosh Hilton. Even there, Bob Hoover made a typically smooth elevator takeoff and landing. I'm not sure he was current to carry passengers in that Otis Model 1301, but it was a great ride anyway. FAR 91.307 Parachutes and Parachuting. Pilots often confuse the parachute rule with the aerobatic flight rule. The parachute rule states that unless each occupant of the aircraft is wearing an approved parachute, no pilot carrying any person other than a crew member may execute any intentional maneuver that exceeds a bank of 60 degrees relative to the horizon, or a nose-up or nose-down attitude of 30 degrees relative to the horizon. The aerobatic flight rule, FAR 91.303, never mentions the aircraft's pitch or bank. It only talks about abrupt or abnormal maneuvers or accelerations. It's technically possible to perform an aerobatic maneuver and not be required to wear a parachute. Simply pointing the nose downward at a 29-degree angle and radically pulling up to a 29-degree angle might be considered an aerobatic maneuver since it's abrupt and certainly abnormal. It doesn't, however, require a parachute. I use this example only for clarification. Do not attempt to do this at home. Without a doubt, a snap roll, loop, or Cuban 8 is an aerobatic maneuver requiring parachutes. If you are by yourself in an aircraft, parachutes are never required, regardless of the aircraft's pitch and bank. The FAA figures that you have enough common sense to measure risk for yourself. When it comes to the passengers, though, they aren't betting on your risk assessment abilities. Parachutes are not required when on flight tests for pilot certification. They are not required when practicing spins or other flight maneuvers required by regulations when given by a certified flight instructor. If you're thinking about carrying any parachute in your airplane, it must be an approved type and have been packed within a specific time. If the chute is a chair type, then it must be packed by a certified and appropriately rated parachute rigger within the preceding 120 days. Any other type of parachute must be packed within either 60 or 120 days, depending on the type of material from which it is constructed. See the actual regulation for a detailed description of this requirement.
A fellow pilot, we'll keep him anonymous, had an unusual occupation. He threw people out of airplanes, parachute jumpers. Flying a Cessna 206 with the door removed, he would hold the brakes as jumpers exited the plane. These folks would grab onto the strut and stand on the locked wheel. Upon the jump master's command, these jumpers would let go of the strut and sink into an ocean of air. On one flight, the last jumper got cold feet, literally and figuratively. He stood on the wheel, holding the strut, but refused to let go. The jump master yelled, "Jump, jump!" The reluctant jumper said, No, I'm not going." Both the jump master and the pilot looked at each other, and the pilot knew exactly what to do. He let go of the brakes. What a rat. While this is not what pilots normally mean when they refer to rotation, it worked. The strut clinger suddenly became a skydiver.
FAR 91.313 Restricted Category Civil Aircraft Operating Limitations. When an airplane is given its airworthiness certificate, it is assigned a category. Most airplanes are certified as standard category, but some are committed to special or restricted category. This means they are to be used for one purpose only. Crop dusting aircraft are one example of this. A few of these aircraft are certified to fly carrying 50% more weight than would be permitted under standard category limits. That's why there are restrictions. A restricted category aircraft can only be used for the special purpose for which it was certified. It cannot be used for flight involving compensation or hire when a passenger is being carried. If you show up at the airport for flight training and your flight instructor shoves you into a crop duster, something is definitely wrong. He shouldn't be providing you with basic flight training while dusting a few crops on the way home. Crop dusting aircraft cannot be operated over a densely populated area, on a congested airway, or near a busy airport where the airlines fly. Frankly, the thought of a crop duster flying over my house doesn't exactly thrill me. If I have bug problems at home, I'll call the ground-bound pest control people. FAR 91.319 Aircraft having experimental certificates. Operating limitations. Some aircraft have experimental certificates. This doesn't mean you can do experiments in these airplanes either. It means the airplane was constructed according to rules different than those under which a standard production airplane is built. Home-built aircraft, otherwise known as kit planes, fall into this category. Until it's proven to the FAA that a home-built aircraft is safe to fly, no person can operate that aircraft outside a designated area. Passengers may be carried, but passengers and property can't be carried for compensation nor hire. The pilot is required to advise each person carried of the nature of the aircraft. In other words, he or she must say something like, "By the way, I just wanted to let you know that I built this thing, and there's nothing wrong with it anymore." This statement is usually followed by, "Hey, wait, come back, don't run away, I was only kidding." Gee. Home-built, constructed correctly, are quite safe. Flight operations may be conducted under day VFR conditions only, unless the FAA specifies otherwise. When operating out of airports with operating control towers, the pilot must notify the tower of the experimental nature of the aircraft. These experimental aircraft may only be used for the purpose for which their certificate was issued. An experimental aircraft cannot be operated over a densely populated area or on a congested airway. Pilots of experimental aircraft may apply for a waiver to these two rules. Perhaps you've seen one of those largely promotional and experimentally certified hot air balloons that drifts around the country touting various companies and products. There is one in particular that impresses me. It's a large cow, hundreds of feet tall. I suppose if you listen carefully enough, you could probably hear the instructor saying, "A more right udder. Give it more right udder." FAR 91.403 Aircraft Maintenance General. Flying an airplane is a safe activity because of the FAA's strict maintenance policy. That's why it's extremely rare for modern aircraft to suffer mechanical difficulty. Regulations place primary responsibility for maintaining an aircraft in an airworthy condition on the owner or operator. The owner is the person who has legal title to the aircraft, but this isn't always the person in charge of its maintenance. When an airplane is leased back to a flight school, the fixed-base operator is now the person legally responsible for maintaining that aircraft. FAR 91.407 Operations After Maintenance, Preventative Maintenance, Rebuilding, or Alteration. This regulation states that no person may operate any aircraft that has undergone maintenance, preventative maintenance, rebuilding, or alteration unless it has been approved for return to service by a qualified mechanic, and a maintenance record entry is made in the aircraft's logbooks. Airplanes have airframe, engine, and propeller logbooks. These are the maintenance records, where the required inspections and return to service statements are logged. Have you ever wanted to be a test pilot? Well, here's your chance. This regulation also states that no person may carry another person, other than crew members, in an aircraft that has been maintained, rebuilt, or altered in a manner that may have appreciably changed its flight characteristics or substantially affected its operation in flight, unless the following is done. An appropriately rated pilot with at least a private pilot certificate must fly the aircraft, make an operational check of the maintenance performed or alteration made, and log the flight in the aircraft records. Translation: anyone with a private pilot certificate can become the test pilot.
Now, boys, suppose you put a waterbed, disco strobe light, and a wet bar in the back of your Cessna 172. This would certainly be a major alteration requiring a flight check before passengers are carried. Realistically, you wouldn't put these things in your airplane. But you might have previously suffered major wing damage requiring a test flight of the wing repair prior to the carriage of passengers. The maintenance records is where the operational check must be logged. I say you get out your old pen and nip it. Nip it in the bud. Bud nip it.
FAR Part 43, not shown in this book, allows airplane owners to do specific preventative maintenance tasks on their airplanes. This doesn't mean major overhauls and airframe repairs. An FAA inspector doesn't expect to see pistons and cylinders lying around on your hangar floor. It does, however, mean that a private pilot or hire can do things like changing spark plugs, replenishing hydraulic fluid, and servicing landing gear and wheel bearings. The entire list is spelled out in the regulations. If you're doing preventative maintenance on your airplane, you're required to complete specific paperwork. This entry must include the signature, certificate number, and kind of certificate held by the person approving the work. That could be you, the person doing the work. A description of the work must be entered in the aircraft maintenance records. FAR 91.409 Inspections. If you elect to operate an aircraft, it must have had an inspection within the preceding 12 calendar months by a qualified mechanic and been approved for return to service. This is typically called the annual inspection. Since gliders don't have engines, they have only an airframe maintenance logbook. Aeroplanes actually have 3 logbooks, one for the airframe, one for the engine, and one for the propeller. Required inspections and maintenance must be logged in the appropriate logbook or logbooks. In addition to the annual inspection, a 100-hour inspection is sometimes required. If you are carrying any person other than a crew member for hire, or if you are giving flight instruction for hire in an aircraft, that aircraft must have had an inspection within the preceding 100 hours of time in service. This is known as a 100-hour inspection. Who names these things? And is usually less intensive than a typical annual inspection. Of course, if you have had an annual inspection, this obviously counts as a 100-hour inspection. The 100-hour inspection must be entered in the aircraft maintenance records. On several occasions, our flight school had to exceed the 100-hour limit to fly the airplane to an airport where the maintenance was performed. Such activity is perfectly legal, although the 100-hour time limit may be exceeded by not more than 10 hours. The excess time used to reach a place where the inspection is done must be included in computing the next 100 hours of time in service. In other words, if we exceeded the 100-hour limit by 3 hours, the next 100-hour inspection was due in 97 hours. FAR 91.413 ATC transponder tests and inspections. Transponders may not be operated unless they have been tested and inspected within the preceding 24 calendar months and found to comply with the appropriate regulations. FAR 91.417 Maintenance Records. Each registered owner or operator of an aircraft is required to keep records of aircraft maintenance. These are the records containing the annual inspection, the 100-hour inspection, major alterations or repairs, and the completion of other required maintenance. A frequent and additional inspection that might be performed on an aircraft often results from something known as an airworthiness directive. When a particular mechanical problem occurs with an aircraft, the FAA may issue an airworthiness directive or AD. This is sent to the owner or operator of the aircraft. It's the owner or operator's responsibility to provide the maintenance required by that AD. When the mechanic completes this maintenance, an entry is made in the aircraft logbooks identifying the AD has been complied with. National Transportation Safety Board Regulations. The National Transportation Safety Board is the agency responsible for aircraft accidents, incidents, and overdue aircraft. Under certain conditions, you may have to notify them or file a report if you are involved in an aircraft accident in which any person receives serious injury or the aircraft receives substantial damage. Part 830 of the Board's regulations governs the reporting of accidents, incidents, and damage to aircraft, cargo, mail, or injury to required crew members. NTSB 830.2 Definitions. It's important that you know the definitions of serious injury and substantial damage, since many of your reporting obligations depend on deciding whether someone has sustained a serious injury or an aircraft has sustained substantial damage. The NTSB has 5 specific definitions for a serious injury. Looking at them closely, they appear to be what you might see at any hockey game. A serious injury is any injury which 1. Requires hospitalization for more than 48 hours, commencing within 7 days from the date the injury was received. 2. Results from the fracture of a bone, except simple fractures of the fingers, toes, or nose. 3. Causes severe hemorrhages, nerve muscle, or tendon damage. 4. Involves any internal organ. 5. Involves second or third degree burns or any burns affecting more than 5% of the body surface. Substantial damage is defined as damage or failure which adversely affects the structural strength, performance, or flight characteristics of the aircraft, and which would normally require major repair or replacement of the affected component. The following are not considered to be substantial damage for the purposes of this part. 1. Engine failure or damage limited to an engine if only one engine fails or is damaged. 2. Bent fairings or cowling, dented skin, small puncture holes in the skin or fabric. 3. Ground damage to rotor or propeller blades and damage to landing gear, wheels, tires, flaps, engine accessories, brakes, or wingtips. An accident is an occurrence in which any person suffers death or serious injury, or in which the aircraft receives substantial damage. An incident means an occurrence other than an accident, associated with the operation of an aircraft, which affects or could affect the safety of operations. NTSB 830.5 Immediate Notification. The operator of an aircraft must immediately, and by the most expeditious means available, notify the nearest NTSB field office when an aircraft accident or any of the following listed incidents occur. 1. Flight control system malfunction or failure. 2. Inability of any required flight crew member to perform his or her normal flight duties as a result of injury or illness. 3. Failure of structural components of a turbine engine, excluding compressor and turbine blades and vanes. 4. In-flight fire. 5. Aircraft collide in flight. 6. Damage to property other than the aircraft, estimated to exceed $25,000 for repair, or fair market value in the event of a total loss. In other words, you land on a large house or a small Mercedes. 7. An aircraft is overdue and is believed to have been involved in an accident. NTSB 830.10 Preservation of aircraft wreckage, mail, cargo, and records. This regulation basically states that if you are the operator of an aircraft involved in an accident or incident, it's your job to protect the wreckage and everything associated with that wreckage until the NTSB arrives and assumes responsibility. Avoid disturbing the wreckage. Do so only if it's necessary to help persons injured or trapped, to protect the wreckage from further damage, or protect the public from injury. If you need to move the wreckage or anything associated with it, make notes, take photographs, or draw sketches to detail its original condition. NTSB 830.15 Reports and statements to be filed. The operator of an aircraft must file a report within 10 days after an accident, or after 7 days if an overdue aircraft is still missing. A report on an incident for which immediate notification is required shall be filed only as requested by an authorized representative of the board. Those are some of the important regulations necessary for flying safely. Of course, some of you may be thinking there's only one thing more boring than studying the FARs, and that's listening to golf on the radio. Okay, let me make this a little more exciting for you by introducing you to our next subject, airport operations. At this time, it is suggested you review the illustrations and photographs in Chapter 6 of Rod Machado's Private Pilot Handbook. Chapter 7, Airport Operations. No doctor needed. Have you ever wondered what all those small trucks at airports, the ones with the flashing yellow lights, do? I thought I knew. For a long time, I was convinced they brought sandwiches to the student pilots who became lost on the airfield. After all, even students need sustenance while attempting to navigate from taxiway to runway to parking spot. An airport's signage and markings are one situation where consistency makes for confidence, and the FAA lends a helping airfoil by specifying in great detail how airport runways, taxiways, and other aircraft movement areas are to be laid out, marked, and lit. While it's not quite true that if you've seen one airport you've seen 'em all, there is a method to the apparent madness. Just like a Buck Rogers secret decoder ring, you just have to decipher what's in front of you. Let's imagine an airport that is graced with 2 runways, thereby being capable of handling takeoffs and landings in 4 different directions. 2 directions on each of 2 runways, for the geographically challenged. Let's assume our airport is a tower airport, and knowing that controllers get so upset when you land on a different runway from the one they had in mind, it's helpful to know that runways come with numbers, which are always large and painted in white. Runway numbers and their markings help distinguish them from the airport's non-landing surfaces. Let's say our runways are numbered 8, 26, 21, and 3. To think of those numbers differently, think of the number 8, the number 26, the number 21, and 3. You think they just make those numbers up, don't you? I had a student who thought runway numbers were based on some sort of speed limit or seismograph record. There's a method to the madness. The numbers represent the first 2 digits of the runway's actual 3-digit magnetic direction. Essentially, a runway's numbers are its direction, rounded off to the nearest 10 degrees. A runway oriented at 211 degrees becomes runway 21. Pronounced runway 21 when speaking to controllers and other aviation-savvy people. A runway pointed 076 degrees becomes runway 8. We round it up. There are 2 sides to almost every issue, and 2 ends to every runway. With rare exceptions, usually having to do with terrain, you can theoretically land or take off from either end. This means each piece of runway pavement has numbers on each end. Those who are way ahead of me will realize these numbers, when expressed as 3-digit figures, differ by a value of 180. Makes sense, since the 2 directions are 180 degrees apart. All runway angles are oriented to the magnetic North Pole, where the magnetic compass points, and not the true North Pole, where Santa Claus, a pilot, lives. When your aeroplane is pointed down any runway, the aeroplane's magnetic compass should approximately indicate that runway's direction. In Chapter 14, you'll learn more about magnetic and true direction. For now, just remember this when operating at an airport. Wind direction, landing direction, and any headings ATC asks you to fly are all based on magnetic direction. Runway lighting. Painted white runway markings are easy to identify during the day. But what about at night? Don't look for day-glow orange anytime soon. The airport has an image to maintain. Besides, the airport would become a magnet for rock stars and flower-painted VW buses. The answer at night is light. As the sun sinks slowly into the west, the airport often lights up like one of those Disneyland Main Street parades. All kinds and colors of lights, some flashing and some steady, are there to amuse and confuse you. Think of it as color-coded hints, and you'll be on the right track. White lights border both sides of the runway. Called runway edge lighting, these lights are spaced 200 feet apart. Controllers turn these lights on between sunset and sunrise, or when the visibility is poor. The beginning of the runway is announced with green threshold lights, while the far end of the runway is lit in red. It's an appropriate color to indicate you are running out of usable landing surface. Only tractors, bulldozers, and dune buggies beyond those red lights, please. These lights actually lead a dual life. On one side they're green, on the other red. Think about it for a second. The beginning or threshold of one runway is the end of another. The lights on the threshold of runway 21 are also at the terminus of runway 3. What I've described so far is the basics of runway lighting, which you will encounter at almost any airport that supports night operations. It can and does get a lot fancier. While gathering aviation experience, you're sure to come across airports with sophisticated lighting. In fact, airports with precision instrument runways can have such detailed lighting that it's possible to mistake it for a prairie fire. Some runways have centerline lighting, with embedded lights running the entire length of the runway centerline. Some have brilliant sequenced flashing strobe lights leading to the runway threshold. Others have touchdown zone lighting, which looks like a gigantic Christmas tree was squished into the first 3,000 feet of the runway. One of my students said it was so pretty, he wasn't sure he should land on it. You can. See the Aeronautical Information Manual for additional information on these lighting systems. Taxiway markings.
There are few things as pitiful as a pilot on the ground, even in the daytime. The king or queen of the airways can easily become the lost platoon when the gear hits the ground. It is a common misconception that pilots are endowed with some superior ability to find their way around airports. This is untrue. Most pilots can find a vending machine blindfolded, but many of us have trouble getting from the runway to the tie-down spot at an unfamiliar airport. Pilots and their airplanes have been extracted from some very unusual places, like the time a fellow pilot accidentally taxied into a secret military hangar at a combo civil-military airport. It obviously wasn't much of a secret since they were in the habit of leaving their doors open.
At larger airports, and even at smaller ones when ground traffic or construction exists, it's not unusual for a tower controller to offer a complex taxi clearance. Here's such a clearance. November 2132 Bravo. Taxi to runway 21 via Charlie, southwest to Delta, turn left, cross runway 21 and make a left turn on Golf. Over. Students normally respond to this clearance with a, "Huh?" If you had an airport chart out in front, you could easily navigate from one position to another without getting lost. Many varieties of airport charts are available to make airport ground navigation easier. Taxiways are identified by a continuous yellow line with parallel double yellow lines on the outer edges of the taxi surface. Taxiway names are shown by small signs. Placed along the side of the taxiway, these signs consist of yellow lettering on a black background. Signs containing black lettering on a yellow background indicate the position of intersecting taxiways. Arrows indicate the relative direction of these intersecting taxiways. At night, many, not necessarily all, taxiways have blue omnidirectional sideline lighting. At some airports, taxiways may have embedded green centerline lighting.
One time, Rod caught an empathetic and sensitive student of his weaving between the embedded green taxiway lights. Rod thought she was having a NyQuil flashback until he found out she was afraid of damaging either the lights or the tires. You won't hurt the lights or the tires, but feel free, if you wish, to keep the nose wheel a few inches to the side of the embedded lighting.
As a pilot, you must be able to identify the point where the taxiway ends and the runway begins. This transition is identified by 4 yellow lines, 2 solid and 2 dashed, crossing perpendicular to the taxiway and running parallel to the runway. These markings are known as runway hold markings. If the two solid lines are on your side, then, at a tower-controlled airport, a clearance is required to enter the runway. If the double broken dashed lines are on your side, then you should cross those lines to clear the runway and enter the taxiway. From now on, we'll assume that a controlled airport is one having an operating control tower. Assuming you have just landed and are taxiing off the runway, you should taxi across the double broken dashed lines and clear the runway. The FAA assumes that your aeroplane hasn't cleared the runway until the entire airplane, down to the last rivet, is on the other side of those broken double yellow lines. The reason for this is to prevent the tails of long aeroplanes like a stretched DC-8 from poking out onto the runway. This could make landing quite challenging for another pilot and possibly give him or her an extra EKG blip. At airports without an operating control tower, meaning the airport has no control tower or the tower has been shut down for the night, entering an active runway is done at the discretion of the pilot. From now on, an airport having no control tower, or one at which the tower is not in operation, will be referred to as an uncontrolled airport. In this instance, you should hold short of the runway, behind the solid taxiway hold lines. Taxi onto the runway only when it's clear of traffic and no airplanes are on short final, in other words, getting ready to land. Look carefully before taxiing onto the runway. The last thing you want is for someone to do a touch and go on you, and making another pilot go around won't win you many friends at the airport. It's also a good idea to broadcast your intentions on something known as the Common Traffic Advisory Frequency, CTAF, sometimes pronounced CTAF, when no tower is in operation. This lets other pilots in the traffic pattern know what you're doing. More on this later. Another way to identify where the runway begins is with a white on red sign located next to the dashed and solid double yellow lines. These information billboards are called runway holding signs, though they don't actually hold anything. They exist to inform you when you're about to enter an active runway. They also indicate the runway direction. At controlled airports, these signs are your cue to hold your position, unless a clearance has been given to enter or cross the runway. At uncontrolled airports, the runway hold signs indicate that you can proceed across or onto the runway when you've assured yourself no traffic conflict exists. An airplane preparing to take off or land is most definitely a conflict. At a tower-controlled airport, these signs are coupled with the double solid and dashed taxiway hold lines, providing ample warning that you're crossing into the action area. Some airports may have taxiways that interfere with the runway safety area. Airplanes landing on the runway could approach low enough to present a problem to both the approaching and taxiing airplane. This is more likely to be a problem for big airplanes, but the rules take into account the worst-case scenario. Such holding position signs for this type of peripheral runway are shown by white on red lettering, and when next to the solid double yellow lines, indicate a mandatory hold point at tower-controlled airports. On the opposite side of the runway, on the back side of the runway hold sign, is a runway safety area sign, normally found at only tower-controlled airports. This consists of the same marking shown on the taxiway, in other words, the double solid and dashed lines. These signs can be used as a guide in deciding when to report back to a controller that you are clear of the runway. Remember, at uncontrolled airports, pilots must decide for themselves whether to enter or cross a runway.
It's difficult, but not impossible, for pilots to accidentally taxi onto an active runway at a tower-controlled airport. One pilot at a very busy airport taxied right into the middle of an active runway and just sat there, probably waiting for one of those yellow trucks to bring him a sandwich. Completely confused about the tower's directions and unwilling to ask for clarification, he stopped his airplane while a jet was on final approach. The following conversation took place.
3-2 Bravo, do you know where you are?
Yeah, Burbank Airport, dude.
Yes, that's good, but do you see that big Boeing 707 out there on final approach headed directly for you?
Yeah.
Do you want him to do a touch and go on you?
No, dude.
Then you better get off his runway.
The pilot, not wanting to get bounced on by a Boeing 707, immediately exited the runway.
Additional runway markings. Just because there is concrete in the shape of a runway doesn't mean that it can be used for landing. Some runways have yellow chevrons painted on them. This signals that the surface is unsuitable for either taxiing, taking off, or landing. It's basically an aeroplane no man's land. Don't use any portion of this area. It might be off limits because the surface won't support the weight of an aeroplane, even for taxiing, let alone landing, or because the surface is otherwise unsuitable. Planes that venture onto chevrons can find themselves up to their axles in asphalt, trapped like a gigantic fly on a no-pest strip. White arrows pointing in one direction form what is called a displaced threshold. This is a runway area which is not to be used for landing, but on which you can taxi, take off, or roll out after landing. Displaced thresholds often exist as part of a noise abatement effort. By forcing you to land farther down the runway, you maintain a higher altitude on the approach than you would if landing at the very beginning of the runway. A displaced threshold can exist for other reasons, such as the presence of a surface that will support the weight of an aeroplane, but not the impact of an aeroplane landing. There's a big difference. I know this since one of my instructors would call out Richter scale values following my touchdowns.
I won't mention any names, but on occasion professional airline pilots have been known to land at the wrong airport with a full load of passengers. Nothing like bringing your own audience to a faux pas. Several years ago, a pilot did this at an East Coast airport. He accidentally landed at a small training field with nothing but itty-bitty Cessnas and Pipers floating around in the pattern. As he touched down and came to a stop, his wheels punched holes in the thin runway surface. He knew he was in trouble when it took full power just to taxi. A few of the locals came out and said, "Hey, look here, look what you did to our runway. You put divots in it. I just can't believe it." The only way they could get the airplane out was to completely strip it down to bare-bones metal, making it light enough to take off without further runway damage. The same could not be said for the pilot's career.
Airport beacons. Airports have rotating beacons to make them easier to find at night. Civilian airports with runway lights have a two-color rotating beacon that alternately flashes green, white, green, white. Military airports, on the other hand, have rotating beacons that alternately flash green, white, white, green, white, white. The two white flashes flash very quickly. A lighted heliport has a rotating beacon that flashes green, yellow, white. I mention the heliport lighting because if you try to land at a heliport, I guarantee the runway will be extremely short. On sectional charts, an airport may have a small star near the airport symbol. This star indicates the presence of a rotating beacon at the airport. Rotating beacons, and by the way, some flash instead of rotate, are normally on between sunset and sunrise. If an airport's beacon is up and running during the daylight hours, it means that the airport is below basic VFR conditions. In other words, ceiling is less than 1,000 feet above ground level and/or visibility is less than 3 miles. Of course, if the visibility is that bad, you probably can't see the beacon until you've violated all kinds of airspace. But they turn it on anyway. In such conditions, a special VFR clearance is required if Class B, C, D, or E airspace exists at the airport. The traffic pattern. If you've ever seen moths dancing around a light bulb, you'd understand why airports have traffic patterns. If it weren't for some organization, aeroplanes might fly frenetically over, above, and to the side of runways, vying for a position to land. Fortunately, it's not like that. We have traffic patterns that impose a respectable and safe order on the flow of traffic at airports. These patterns are usually rectangular in shape, with each portion having a specific name for easy identification. All airports, controlled and uncontrolled, have traffic patterns. At controlled airports, air traffic controllers manage the flow of traffic. This becomes especially important when the airports are extremely busy. While it's obvious that airports such as Los Angeles, Chicago, and New York need towers, there are many general aviation airports which also have a heavy volume of traffic. At such airports, pilots simply fly the established traffic pattern, while controllers verbally coax them into an orderly sequence. At airports with less activity, it's difficult to justify establishing an air traffic control tower. At these non-tower airports, pilots typically fly the airport's traffic pattern on their own. They are left to their own devices in deciding their landing direction and sequence among other aircraft in the pattern. If the idea of a lot of pilots flying around near an airport without someone telling them what to do raises a few questions, then you have at least a modicum of common sense. Believe it or not, things work out remarkably well because pilots are reasonably adept at following rules. Much of aviation depends on there being a high degree of predictability. Knowing what pattern another pilot is flying or is likely to fly is the key to making the system work for everyone. That's why the concept of the traffic pattern is so important. The traffic pattern represents a very standardized way for pilots to depart from or land at an airport. If everyone does what they're supposed to do in the traffic pattern, then everybody's actions become quite predictable. Once you know where you fit in the sequence of traffic, you will know what is going on, and when it is your turn to take a particular action. Let's take a closer look at the airport traffic pattern and what you will do once you're in one. Traffic pattern components. Traffic patterns are rectangular in shape and consist of 6 segments: departure leg, crosswind leg, downwind leg, base leg, final approach, and upwind leg. Aeroplane takeoffs are made into the wind, and the takeoff flight path is thus called the departure leg. After takeoff, you have 2 major choices. You can either depart the airport traffic area, or you can remain in the pattern, which means you will fly a prescribed path, come around, and land on the runway you just departed from. This is done by pilots who enjoy very short flights, as well as by pilots who are practicing landings. From time to time, we pilots remain in the traffic pattern in order to polish our skills and minimize the explanations to passengers for our occasional bad landings. If you're remaining in the pattern, a turn, generally a left turn, to the crosswind leg will be made when the aeroplane is beyond the departure end of the runway and within 300 feet of the traffic pattern altitude. This portion of the pattern is called the crosswind leg because the flight path is perpendicular to the runway and generally crosswise to the wind direction. One time I asked a student what leg he was on in the traffic pattern. He replied, "I'm on my right leg, but plan on using my left leg once the right one gets tired." Of course, immediately asked if anyone had delivered him a sandwich lately. As the aeroplane continues its climb, another 90-degree turn is made. This places the aeroplane parallel to the runway, going opposite to the direction in which it will land. This is called the downwind leg, because your direction is with the wind. Throughout the upwind, crosswind, and even part of the downwind leg, the aeroplane continues to climb until reaching traffic pattern altitude. This altitude varies from one airport to the next because of terrain, obstruction, and noise concerns. Expect traffic pattern altitudes to range from 600 to 1,500 feet above the airport elevation, typically averaging about 1,000 feet AGL. The downwind leg is flown approximately 1/2 to 1 mile out from the landing runway. This keeps you comfortably close to the runway. In the event of an engine problem, you can glide to a safe landing. You continue downwind until passing a point abeam the beginning of the landing threshold of the runway. Then it's another 90-degree turn and you're on base leg. From here you make one more 90-degree turn onto final approach. The upwind leg is flown parallel to the runway in the direction of landing. It's often used during go-arounds or overflights to avoid departing aircraft. Assuming traffic isn't a factor, it's convenient and practical to start your turn onto base leg when the landing threshold appears 45 degrees between the tail and the wing of your aeroplane. In other words, as you look out the left window, the threshold appears to be at a 45-degree angle to the left of the wing, or midway between the wing and the tail. This provides you with a symmetrical, rectangular-shaped pattern and gives you enough distance from the runway to make a comfortable approach.
Aviation is one place where it is not good to become a homeboy or homegirl. Some students fudge by using familiar landmarks on the ground to tell them when to make their turns. This is bad because it leads to a lack of flexibility. If you need the local Burger Boy restaurant to land, what will you do when you go to a new airport? There's nothing more pitiful than a pilot who can only fly to and from his or her home airport comfortably. I've seen student pilots come absolutely unglued when they weren't allowed to turn base at their landmark. You will not always be able to turn base or final at an ideal time, and the ability to make adjustments is crucial. When traffic is heavy, you may have to fly the downwind leg for some distance past the airport before turning base leg. On one occasion, there were 20 aircraft in the pattern. One pilot was so far downwind that the controller called and asked,
4-5 Charlie, what time zone are you in now?
Base leg is a point of transition for landing. It's the place where important adjustments are made in the aeroplane's speed and landing configuration. This is why, even when there is little or no traffic, you should avoid turning base too early. Things happen mighty fast as you approach the runway. You want to give yourself enough time to adjust your airspeed, flaps, and glide path. The descent for landing is normally started on base leg and continues throughout the final approach. The final approach, sometimes just called final, is a critical part of the landing sequence. Generally, a square turn from base onto final approach is best. This provides you with enough time to observe your aeroplane's descent path and alignment with the runway. You can observe and correct for the effect of crosswinds on the aeroplane if you give yourself a reasonably long final approach. During the final approach, the aeroplane's glide path can be adjusted using flaps, slips, or S-turns, making it easier for you to land on any selected runway spot. When turning from base leg onto final approach, you have an additional opportunity to correct your glide path. Let's assume that you are making a power-off approach from the base leg. After turning base, you retard the power and commence descent. Your objective is to land on the runway numbers, the ones at the beginning, not the end of the runway. unless you want a sandwich. If you're too low, you can cut short the turn from the base leg to final approach. If you're too high, you can deliberately overshoot the turn onto final approach, giving you more distance to cover during your descent. Another option is to S-turn on final. S-turns are simply a series of alternating turns left and right of the direct glide path. Since the shortest distance between any 2 points is a straight line, anything you do to fly other than a straight line lengthens the trip. Assuming a constant rate of descent, taking the long way home will allow you to lose more altitude. S-turns, coupled with forward slips and use of flaps, provide you with several ways of adjusting your glide path. This knowledge becomes especially important when a precision landing is necessary, such as on a short field or in the event of an engine failure, when you generally get only one opportunity to hit the safe landing spot you've chosen. With a little practice, you will be able to put the aeroplane down in the precise place you want. We won't discuss forward or side slips in this book. Any good aviation procedures book should have information on this subject. Crabbing in the pattern. No, this isn't what happens when your instructor doesn't get enough sleep, though it definitely describes how the instructor, the tower, and the other pilots will act if you don't learn how to take account of the wind and adjust for its effects on your aeroplane. The path your aeroplane traces over the ground is called its ground track. If you sit there fat, dumb, and happy, with your compass showing a 165-degree heading, you will track a 165-degree heading over the ground from any given point only when there is no wind or the wind blows directly on your nose or tail. Think of the wind as being a giant hand. Because the aeroplane doesn't have its feet on the ground, it gets pushed around by the wind. Depending on how much wind there is and what angle the hand is pushing from, the effect can be anywhere from slight to considerable. The only way to create a straight ground track is to compensate for whatever wind there is by pointing the aeroplane's nose slightly or more so, depending on the conditions, into the wind. If you head the plane to the right a bit, and the wind pushes you to the left a bit, everything balances and you make your intended straight line over the ground. Since crabs face one way and walk another, that's where we get the term crabbing. How do you know the precise amount to crab? You simply make a slight turn, say 5 degrees or 10 degrees at first, into the wind, level the wings, and watch the results. If the aeroplane is crabbed properly, it will make a rectangular ground track about the runway. The aeroplane's ground track is now perpendicular to the runway. Of course, if the wind is not directly aligned with the runway, you'll have to crab on all 5 segments of the traffic pattern to maintain a rectangular ground track. If you let yourself get pushed around by the wind, you won't be where you're supposed to be. This is a particular problem in the traffic pattern. Remember a while ago I said predictability was important? Other pilots in the tower expect you to fly a traffic pattern that tracks straight on each leg, and crabbing to take account of the wind is the only way to do it. Entering the traffic pattern. So far, we've been talking about taking off and staying in the pattern, and we've been talking about flying at a tower-controlled airport. What happens when you are arriving at an airport to land and there's no tower to issue instructions? Before entering the traffic pattern at uncontrolled airports, you are expected to observe the flow of traffic and conform to the traffic pattern in use. In other words, you shouldn't be going in a direction different from anyone else. Doing so is not polite, smart, safe, or sanctioned. So avoid doing this unless you want to end up on one of those TV shows like Cops Rescue 911 or America's Most Wanted. Okay, you want to do what's right. How do you find out what that is? You need two pieces of information in order to figure out a traffic pattern: the runway in use and the direction of turns in the pattern, in other words, left or right traffic. The runway in use is normally determined by the wind direction. With rare exceptions, you take off and land into the wind. The exceptions, which are very rare, would be situations where the airport is situated in such a way that you can only land in one direction, no matter what the wind. This generally has to do with terrain obstruction or other geographical oddities. You don't need a weatherman to know which way the wind blows. You do, however, need either a windsock or a report from the ground. Windsocks look like brightly colored nets for capturing butterflies on steroids. They are supposed to be easily visible from the air. This is one of those aviation secrets, but I'm going to tell because you've been nice enough to listen thus far. Windsocks are not usually easy to spot, and when they are, it isn't always easy to figure out what they're telling you. In theory, the fat end is facing into the wind, and the narrow end is pointed toward the end of the runway where you'll land. This is most easily seen while standing on the ground next to the windsock. Try to discern it while 1,000 or more feet in the air, traveling 150 miles per hour, and keeping the airplane upright is a bit more of a challenge. There is often an easier way to get the information. Many uncontrolled airports have what is called a unicom. This is the authorized frequency on which someone, usually the operator of one of the refueling and repair operations, in other words, fixed-base operators or FBOs in pilot speak, provides information on the wind and traffic pattern directions. The unicom information is advisory in nature only. Unicom operators are not air traffic controllers. They cannot issue commands, sequence traffic, etc., though they will usually advise you if there are other aircraft in the pattern or inbound. Another option is a multicom frequency. This is a frequency approved for air-to-air use. Other pilots in or around your destination airport will generally help out with information on request. If information is not available from either unicom or multicom, then you have to take clues from wherever you can on wind direction, such as smoke, waves on the lake or ocean, and should refer to the segmented circle located at the airport for directions on the type of traffic pattern to fly. Segmented circles are often constructed of large white blocks, bricks, or ground paintings. These circles contain several additional items to help you decide upon the proper runway for landing as well as the appropriate traffic pattern to fly. I'll explain how to interpret the segmented circle shortly. Segmented circles are segmented so they are easier to identify at higher altitudes. If you are unaware of the proper traffic pattern, simply fly over the airport and look for the segmented circle. The proper way to do this at an uncontrolled airport is to overfly the field above the traffic pattern altitude and observe the indicator. Usually 1,000 feet above the established traffic pattern altitude is sufficient to avoid the flow of airport traffic. In other words, if the traffic pattern altitude is 700 feet AGL, and you're an additional 1,000 feet above that, this puts you at 1,700 feet AGL. At this altitude, you can easily observe the segmented circle without unexpectedly bumping into people who are minding their own business and trying to land. At controlled airports, air traffic controllers will inform you of the runway on which to land and the appropriate traffic pattern to be flown. Some people are just born do-it-yourselfers, and they want to determine for themselves the lay of the land. It is often very helpful to see which way the runways run before attempting a landing, especially if visibility is less than optimal. In fact, I prefer that students unfamiliar with the complex taxiway and runway layout of an airport overfly the field and observe its runway and taxiway layout before attempting to enter the pattern. Things can get pretty confusing down close to the ground, and the overflight helps orient you to a runway direction. Once you gain a little experience, you can plan on skipping this overflight and enter the downwind at a 45-degree angle. To overfly a controlled field for a preliminary look-see, just ask the controller for permission to overfly at whatever altitude you want that is safely above the traffic pattern. Such a request will almost always be approved. If you really want to take a look first, before even engaging the controller, keep in mind that Class D airspace normally ends at 2,500 feet above the ground. You can overfly at any altitude above that boundary without the need to tell anyone what you're doing. Then, when you're ready to enter the traffic pattern, you simply establish and maintain communications with the tower and enter the pattern. More on how to call the tower and what to say later. Remember, we're talking about overflying an airport in Class D airspace here, not Class C or B airspace, which extends to higher altitudes.
A few years ago, a student pilot got hopelessly lost on a solo cross-country. He spotted a controlled airport and commenced circling the field at a few hundred feet above the tower. Fortunately, the pilot knew enough to transmit on the emergency frequency of 121.5. The tower heard a transmission that went like this.
Well, the tower that has a small airplane circling above it, with me in it, please identify yourself.
The tower replied, "This is Long Beach Airport. What are you doing up there?" The pilot replied,
Well, I'm lost. Well, I was lost, but thanks to you, I think I just found myself.
They cleared him to land on runway 25 left. When the pilot said he wasn't familiar with the runways, the tower said to pick out any piece of asphalt at the airport and land on it. Of course, I'm sure all the controllers were placing bets on what kind of sandwich this pilot liked.
The segmented circle. The segmented circle contains several useful pieces of information, once you know how to read the hieroglyphics. Attached to the segmented circle are the landing strip indicators and the traffic pattern indicators. The landing strip indicators are aligned with and represent the airport's runway or runways. They are shown by the two strips located either side of the segmented circle. Attached to each end of landing strip are the traffic pattern indicators. Because of this combination, the landing strip and traffic pattern indicator take on an L shape from the air. Basically, the traffic pattern indicators point to the side of the runway on which the traffic pattern is flown. Where two or more runways exist, multiple L-shaped bars may protrude from the segmented circle. What happens if no landing strip indicators or traffic pattern indicators protrude from the segmented circle? Is this a sign of airport vandalism? No. Segmented circles without these indicators imply that you should fly a standard left-hand traffic pattern for the runway in use. Left-hand traffic is considered standard, and pilots should make all turns to the left in the absence of other indications. Right-hand traffic patterns, by default, are considered to be non-standard patterns. Wind and landing direction indicators. Knowing whether it's a right or left-hand traffic pattern is one thing, but what about deciding which way to land? Within the segmented circle, you'll normally find some type of wind or landing direction indicators. Either one of these help you select a runway for landing that's most nearly aligned with the wind. We want to land into the wind whenever possible. It slows our touchdown speed and makes landing safer as well as easier. Three types of indicators are used to identify the proper direction for landing. The first two are known as wind direction indicators, and the last is called a landing direction indicator. The first type of wind direction indicator is the windsock, which I discussed earlier. It's a big help if you can see it. The windtee is another means of determining landing direction. This device looks like a little aeroplane. It's free to rotate around its base, and is aerodynamically constructed so the small aeroplane points into the wind. Sometimes the device isn't free to rotate, and airport personnel manually place it in the proper direction for landing. Either way, you can determine the appropriate landing direction by imagining the wind T as a small aeroplane pointing in the direction that you should land, or nearly so. Simply land on the runway most nearly aligned in the direction the wind T, as it resembles an aeroplane, points. A more direct means of determining landing direction is with a tetrahedron. No, this isn't a prehistoric type of dinosaur either. The tetrahedron is a four-sided object, 3 sides on top and 1 side on the bottom, and is technically called a landing direction indicator instead of a wind indicator. It's a 3-dimensional structure that's usually free to rotate about its base. When it can rotate freely, it points into the wind. When it can't, it is also manually rotated by airport personnel to point in the appropriate landing direction. Determining landing direction is simply a matter of landing on the runway most nearly aligned with the direction the tetrahedron points. Children seen playing on the tetrahedron should arouse suspicion as to the actual direction in which to land. The tetrahedron should be used with caution when the winds are light or calm. These things are large hunks of wood or metal, not ballerinas. It takes at least a modest puff of wind to move one. It's a good rule in general aviation to treat all information with a high index of suspicion until you can confirm it another way. I've had students who were crabbing 60 degrees into the wind while insisting it had to be coming from another direction because they'd heard it on the radio or seen it on the tetrahedron. The aeroplane is the ultimate authority on what's really happening. Some airports have a designated calm wind runway, usually the runway that's less noise sensitive. Under calm wind conditions, airport personnel may manually point the tetrahedron in the direction of the calm wind runway. Be sure and maintain a special vigilance during landings at uncontrolled airports when the winds are calm. This is necessary for 2 reasons. First, another pilot might have chosen another runway, since the wind didn't enforce its will. Second, keep in mind that calm doesn't necessarily mean none, so be prepared for the possibility of a breeze from any angle. Many times the landing or wind direction indicators aren't aligned with any specific runway. This means a crosswind exists at the airport. In these conditions, pick a runway that's most nearly aligned with the wind. With a little practice, you'll have no difficulty handling these crosswind landings. Honest. The 45-degree entry point. Once you know the direction of the landing runway and the appropriate traffic pattern to use, you're ready to enter the pattern in an organized way. The best way to do this is to enter the traffic pattern in level flight at a 45-degree angle to the downwind leg at the approximate midpoint of the runway. This doesn't have to be exactly 45 degrees, but it should be close. This angle of entry allows you to more easily see traffic on the crosswind and downwind legs of the traffic pattern. Seeing these aeroplanes makes it easier for you to blend into the flow of traffic. A 45-degree entry also makes it easier for other aeroplanes in the pattern to see and blend in with you. Of course, if it's a controlled airport, tower controllers will usually advise you of traffic in the pattern. Once again, keep in mind that predictability is important. The controllers expect you to make a standard pattern entry at the standard pattern place. They don't like surprises very much, perhaps because they're responsible for what happens on their shift. Oh, and they are concerned as well. Aim to enter the pattern abeam the midpoint of the runway, and always enter the pattern at the specified pattern altitude for that airport. This allows everyone to be at the same height, making it easier to see other aeroplanes. If no traffic pattern altitude is established, it's usually best to fly the pattern at 1,000 feet AGL if no tower is available to advise otherwise. I do want to make it clear that we're talking about an entry at a 45-degree angle, and not a 45-degree bank to the downwind leg. I gave a phase check to a student pilot who didn't quite understand this. We were approaching the pattern when I reminded him to use a 45-degree entry. He immediately rolled the airplane into a 45-degree bank. Then he asked me for a sandwich. How novel. I'm just glad the FAA doesn't recommend a 90-degree entry. It should come as no surprise to you that the majority of mid-air collisions occur within 5 miles of an airport at an altitude of less than 3,000 feet AGL. In one study, it was 79%. This makes sense, since that's where the majority of the aeroplanes are. The same study found nearly half of all mid-air collisions occurred within 5 miles of an airport at an altitude of 500 feet or less AGL, 49% to be specific. This is a common altitude for a base leg and final approach, isn't it? A word or 3 to the wise should be sufficient here. Pay close attention. Look with your eyes and ears. In other words, listen for the call and position of other aircraft. Departing the pattern also requires that you avoid interfering with traffic entering and remaining in the pattern. First, a departure can be made straight out. A 45-degree turn on the pattern side of the runway is also recommended after the aeroplane has reached traffic pattern altitude. Of course, if there are parallel runways, noise-sensitive areas, or obstructions, then you should follow the recommended procedures for departing that particular airport. These recommended procedures are sometimes found posted near the departure end of the runway. They may also be found in a useful document known as the Airport Facility Directory, the AFD as it's affectionately known to pilots. More on the AFD in Chapter 17. CTAF, Common Traffic Advisory Frequency. The airports you'll land at or depart from will either be controlled or uncontrolled. Operations at controlled airports are accomplished by communicating with an air traffic controller. We'll discuss how to do this shortly. For now, let's examine the proper communication techniques when operating into or out of an uncontrolled airport. Remember, this is an airport without a control tower or one whose tower isn't in operation. At uncontrolled airports, pilots are not required to use their radio to communicate with other traffic during takeoff or landing. Simple see and avoid vigilance is considered satisfactory. Common sense, however, dictates using a radio if one is on board. Aeroplanes with radios tuned to the same common frequency can broadcast their intentions to each other while operating in the traffic pattern. This makes the airport a safer and more harmonious place. At many uncontrolled airports, a frequency known as the Common Traffic Advisory Frequency, CTAF, is available for pilots to communicate their intentions and receive information during takeoff or landing. It's called common simply because all pilots communicating at a particular airport use that frequency. This CTAF may be either a unicom, multicom, flight service station, or tower frequency, if the airport has a tower but it's not in operation at the time. CTAFs are found in several aviation publications, as well as being printed on aeronautical sectional charts. While a unicom frequency can also be the CTAF, this is not always the case. At airports with towers, the tower frequency will usually be the CTAF that's used when the tower isn't in service. Most airports with a tower will also have one or more unicom frequencies. These are not CTAFs in this case. See the AFT or the aeronautical chart for this frequency. Using unicom and multicom for information. If you're landing at an uncontrolled airport, at about 10 miles out, it's time to talk, using the CTAF. If the CTAF is a unicom station, the following phraseology is appropriate.
Corona Unicom, Cessna 12123 Bravo is 10 miles southeast, descending through 3,000 feet, landing Corona. Request wind and runway information, Corona, over. At airports without an established Unicom station, you may ask for landing advisories from traffic that may already be in the pattern. On the Common Traffic Advisory frequency, simply state, Sun Hill traffic, Cessna 2123 Bravo, is 10 miles southeast, descending through 4,000 feet, landing Sun Hill. Request landing advisory, Sun Hill, over.
Without an operating control tower to help inform pilots of each other's position, the Common Traffic Advisory frequency is used to make position reports while in the pattern. In addition to the call 10 miles from the airport, report your position entering the pattern, when downwind, on base, and on final approach. This keeps other airplanes at the airport apprised of your whereabouts. Since there may be another airport in the vicinity on a similar Unicom or multicom frequency, state the airport name during these transmissions. For instance, the following is a typical report for such an airport. Corona Unicom, Cessna 2132 Bravo entering left downwind for runway 25 for touch and go at Corona. Notice that you announce whether you're making left or right traffic. This provides an opportunity for everyone to yell at you if you're going the wrong way. You should also broadcast your intentions on the Common Traffic Advisory frequency when departing an uncontrolled airport. Make a broadcast before taxiing and on the runway before departure. The following self-announced phraseology should be used.
Sun Hill traffic, Cessna 2132 Bravo at Bob Dean's Palace. This is your location on the airport. Taxiing to runway 25, Sun Hill. Sun Hill traffic, Cessna 2123 Bravo, departing runway 7. Departing the pattern to the direction you want to fly. Climbing to the altitude you wish to attain. Sun Hill.
Just because there's no tower doesn't mean that you should use non-standard phraseology. I heard one pilot call the tower and say,
Man in the tower, this is the man and the bird. I'm ready to go, so give me the word.
Man in the bird. This is the man in the tower. You talk funny. The delay's an hour.
The moral to this story is save the poetry for smoky midnight cafes. Avoid slang and stick with accepted word usage. Remember that predictability is important. Other pilots and controllers expect to hear certain information in a certain order. There are airports without an established Common Traffic Advisory frequency. Normally, these are private airports, indicated on your sectional charts by the initials PVT. This doesn't mean that you have to be a private pilot to use it either. It just means that it's privately owned and you should seek permission from the owner if you want to land there. When landing at a private airport, broadcast your intentions on 122.750 or 122.850 MHz. These are the frequencies for air-to-air communications and for private airports that are not open to the public. If you're landing at a non-privately owned airport without any Common Traffic Advisory frequency listed in the AFD or on a sectional chart, use 122.9 MHz to broadcast your intentions. Some airports have a flight service station that provides airport advisory. These flight service stations are physically located on an airport which does not have a control tower or where the tower is operated on a part-time basis. They provide something known as LAA, or Local Airport Advisories, which is non-control information on traffic, runway, wind, altimeter setting, etc. See Airport Advisory Area in the Pilot Glossary. The Common Traffic Advisory frequency for this airport will be shown on the aeronautical sectional chart as well as in the AFD. Typically, the CTAF will be the frequency of the closed tower if a tower exists at the airport. Of course, communications with the flight service station for local airport advisories is optional, as it is with Unicom and Multicom. Take advantage of this service where it is available. The phraseology and recommended distance for the initial call-ups are similar to those for Unicom and Multicom. Because of the consolidation of flight service stations that's occurred over the years, you won't find too many flight service stations providing local airport advisory services. So far we've discussed operations at uncontrolled airports. Uncontrolled airports require that you, on your own, identify the wind direction, runway landing direction, as well as the appropriate traffic pattern to fly. At controlled airports, those with operating control towers, the air traffic controller provides you with this information. This information includes traffic pattern direction, runway to use, directions to fly, as well as position reports to make when approaching the airport. An important point to remember is that you must establish two-way radio communication before entering the controller's airspace, Class C or D airspace, or obtain a clearance if it's Class B airspace.